Okay, so in this conversation, we're going to sort of play out the things that we learned in previous conversations, and we're going to write electron configurations. This is going to end up being shorthand notation that's going to help give lots of insight into the way that atoms act. And so that's why we go to the trouble to learn electron configurations. All right, so first of all, we're going to take something we did previously, and then we sort of implied orbital diagrams. I think I drew one or two orbital diagrams in our last conversation. Orbital diagrams use boxes to sort of visualize where the electrons are, okay? So we know that an S, right, back here to an S, we know that an S, let's see, subshell only has one orbital in it, right? So there's another S subshell that only has one orbital in it. Here's a P subshell that has 3 orbitals in it, right? And if we start giving this system electrons, we'll go 1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons, 6 electrons, right? And so what I didn't tell you in a previous conversation was that all orbitals in a particular sublevel will get at least 1 electron before any get 2, right? They're all going to get at least 1 electron before any get 2. That's why we go 1, 2, and then the third one will go here, of course, before we put 1 here. All right, so that's an introduction to an orbital diagram, and now we're going to introduce you to electronic configurations. Okay, electronic configurations. Now, chemists use electronic configurations to indicate the placement of electrons in an atom, right? To show how electrons fill energy levels and sublevels in order of increasing energy. And they can write it in an abbreviated form, which I'll show you in the next video, to represent all electrons preceding it. That'll make more sense in the next video. We won't say much of anything about that in this one. All right, so the electronic configuration for carbon, for example, in the previous one, the previous slide, we showed 6 electrons, right? I actually did a couple more electrons here. So let's get rid of, let me get rid of that. Come up here, eraser. Okay, right? There's 6 electrons there, right? 1, 2, 3, 4, 5, 6 electrons, right? So if it has 6 electrons, it's going to be carbon. And we would write that electronic configuration then as 1s2, and this represents, or that goes with that. So there's 2 electrons here in that 1s. This 2s has got 2 electrons, so we would say 2s2, and then there's 2 here, and we would say 2p2, and that's what we show here. All right, 1s2, 2s2, 2p2. So the electronic configuration for hydrogen, let's start from the very beginning. Hydrogen only has 1 electron. A hydrogen atom only has 1 electron, right? And it's got only 1 orbital because it's only got 1 subshell, right? So in that case, its electronic configuration is 1s1. Helium has 2 electrons, and so they both, like this orbital has a capacity for 2 electrons, right? So they can both fit in that subshell. So its electronic configuration is 1s2. All right, so here's just an overview of all of the electronic configurations and orbital diagrams for lithium to neon, right? 3 electrons, 4 electrons, right? The 2p starts to get filled up here all the way up to neon. Okay, so let's practice drawing orbital diagrams. Nitrogen atoms are found in amino acids, proteins, and nucleic acids. Draw the orbital diagram for nitrogen. I'm going to pause the video here and ask you to do it. I'm sorry, you're going to pause the video and do it, and then come back and compare your answer to mine. Okay, so hopefully you did that. Nitrogen's atomic number 7. That means it has 7 electrons because it's got 7 protons, right? So its orbital diagram is going to go like this. 1 electron, 2, 3, 4, 5, 6, 7. Okay, so that's the orbital diagram for nitrogen. All right. Oops, that slide doesn't belong here. Okay, that slide doesn't belong here because I just did that. All right, and that's what we're going to stop. We're going to stop now for now. We'll begin our next video with this conversation.